Okay, so let's start creating our first volume simulation. I'll create a geometry container, and I'll call it source. It's going to be where we're going to be creating the source. The first tip I can give you is that one of the most important things when you're creating a smoke simulation is the quality of your source. If you have a good source, then you probably have a good volume simulation or smoke simulation in this case. If you don't have a good source, then it's going to be much harder for you to get an interesting result. Let's create a torus. We'll create some sort of rings of smoke going up. Let's make it smaller. Let's say maybe a radius of 0.2 and here 0.6, 0.1. Yeah, this should give us something interesting. I'm also gonna pull this up. I'll use a transform for that. Just so it's not intersecting the ground. Let's say 0.3, something like that. And this is gonna be our source. The way we're gonna transform this into a pyro source is by using a node specifically for that. So pyro source. The pyro source will basically convert this. We'll grab an object and scatter some particles on it. It has several ways of working. Right now, the mode is keep input, so it's actually grabbing the points from the topology. The other options you have is surface scatter, which makes sense if you have something that's on fire. It makes sense for you to just scatter particles on the surface. Let me turn off the grid, press D and switch these to dark. And the other option will be for you to volume scatter. And if you have a volume, then it makes more sense for you to fill the volume of your object and have it actually become the whole volume, become the source. Here you have the particle separation, which is going to control the density of particles that you have. I'm going to start with 0.025. And what the pyro source does is when you, here on the initialize, you choose your option. So right now we're just going to be initializing smoke. So we just want smoke. The pyro source is going to be doing is on each one of these points, it's going to create an attribute called density and an attribute called temperature, and give it the default value of 1 and 1. If you go to the geometry spreadsheet, you'll see that here you have density of 1, temperature of 1. The next step is going to be for you to rasterize this and basically convert the points into an actual volume that's going to be used as a source inside the pyro solver. So we use rasterize, volume rasterize. Let me just type rasterize. So you have volume rasterize attributes. Connect this. And then we say which attributes we want to rasterize. And in this case, it's going to be density and temperature. And then we'll have another important parameter to determine the detail that you have, the voxel size. Usually you will copy this parameter and go to your pyro source and set the particle separation to be the same as your voxel size. So we go here and paste relative references, and now we have that. So we're going to be controlling the particle density based on the voxel size. Let's say 0.025, and we get something like this. Now, this isn't just one volume. We're actually looking at two volumes. If you middle mouse button here, you'll see that you have a density volume and a temperature volume. This is what's actually going to be the source. Of course, this isn't a very interesting source. It's very uniform, so we need to add a bit more variation here. And there's a node that makes that really easy, which is called attribute noise. The attribute noise is always going to reference the position by default, and it's going to be applying it to the color. But let's switch the signature to 1D, and let's leave it at the color for now so that we can have a better idea of what's happening in terms of the size and the variation of our noise. We will want to animate the noise so that it changes through time. And if you center the noise, you're just gonna tell it to kind of have values that go from -1 to 1, which can be a bit drastic. But you can establish a limit. You can post-process it and establish that the minimum value that you want is 0, and that way you don't have those strange values. We can also remap the noise, making sure that it goes from -1 to 1. Okay, everything that's negative is going to be clamped to 0. And now if we play, I'm going to turn on the real time. If we play, we can see we have this variation happening. It's still on a large scale, so we can come down here and reduce the element size to something smaller so that we just have some kind of variation like that. But we always have kind of a ring shape going on. Other things you can do is play with the roughness. For instance, if you want it to be kind of noisier, smaller detail, I'll keep it at 0.6 for now. But this is the noise that we have and what we're going to be applying to our density. This is going from 0 to 1, so we can use this as not as an additive, but it would be more interesting to actually multiply what we already have for this. So we'll change this to multiplicative, and the attributes we actually want to affect are density and temperature. Now if we go here, you'll see that that's also being reflected on the volume that's going to be used as a source. If we don't want the attribute noise to have such a strong effect, then what we can do is, instead of limiting to 0, you can say, let's just limit it to 0.1. That way you always have some density, but the minimum is always going to be 0.1, so you don't break the shape as much. Now, this is going to be our source for now. Right mouse button, and let's create a null here. As usual, out source. Now that we have a source, let's make sure we have an actual project. So I'm gonna create a new project. I'm gonna call this intro volumes. I'm gonna copy this, Control C, accept, and file save as _001, and this is our source, and we have our file saved. And now we'll move on to actually using this inside a pyro solver.